Our next topic is Ohm's law, which states that the current flowing through a conductor is directly proportional to the potential difference, or voltage, across it, provided that the physical conditions, such as the temperature of the conductor, remain constant. This means that if we increase the voltage, the current increases in the same proportion, as long as the conductor's properties do not change. The graphical representation of Ohm's law is an IV graph, where current is plotted against voltage. This graph is a straight line that passes through the origin, showing a linear relationship. The slope of this line is equal to 1 divided by the resistance, or 1 over R. This linear behavior indicates that the resistance remains constant when the physical conditions are unchanged. Here are the IV characteristics of some materials, including the diode, filament of a bulb, and thermistor. All of them exhibit non-ohmic behavior, meaning their IV graphs are not straight lines. In a diode, initially, the current does not increase significantly with voltage. However, once the voltage reaches a certain threshold, around 0.6 volts for a silicon diode, the current increases rapidly, showing a sharp upward curve. For a filament bulb, as the current increases, the filament heats up, which increases its resistance. As a result, the IV curve bends, showing that current no longer increases linearly with voltage. In the case of a thermistor, especially a negative temperature coefficient or NTC thermistor, the resistance decreases with increasing temperature. So, as voltage increases and it heats up, the current increases more rapidly, resulting in a curve that gets steeper with voltage. Since the resistance of a thermistor depends on temperature, it is commonly used as a temperature sensor. A thermistor is a type of resistor whose resistance changes significantly with temperature. The word thermistor is derived from the words thermal and resistor. Now, why does a thermistor not obey Ohm's law? This is because thermistors are made from semiconductor materials such as metal oxides, including manganese, nickel, or cobalt oxides. As the temperature rises, thermal energy breaks more covalent bonds in the semiconductor lattice, releasing additional free electrons and holes. This increases the number of charge carriers, allowing more current to flow at the same voltage. As a result, the resistance decreases as the temperature increases, leading to nonlinear, non-ohmic behavior.